All right, guys, now we are actually going to start the Unit 6 material. We're going to start talking about polygons. You'll see a lot of different terms, some of which you've seen before, some you haven't, but that's okay. The notes for this are pretty long. It starts on page 6 in your packet, so you're going to want to pull that out. And the notes actually go to page 9. So the notes and the homework are both about 4 pages long. But we're going to spend a couple of days on the practice. So I'm going to split this note video up into 2 just so it's not too overwhelming. So again, turn to page 6 in your packet. It's important that you get these down. We'll talk about a couple terms and then we'll look at some examples. So first of all, a polygon is a closed two-dimensional figure made up of line segments only, but not curves. Enclosed means all the points are connected. The term polygon comes from the Greek word poly, which means many, and gon, which means angles. All right, so when we look at the terms over here, some of these we know. 3-sided figure is a triangle, 4 is a quadrilateral, 5 is a pentagon. The bigger you get, you tend to not know them. Hexagon is 6, heptagon is 7, octagon is 8, 9 is nonagon, decagon for 10, dodecagon for 12. There's a few others, but typically once you have anything above 10, other than the 12, you'll just put however many sides there are and then the word gon after it. So if it's a 16-sided figure, 16-gon. Because it's just saying that there's 16 angles. So with this first example, this is a polygon. It has 1, 2, 3, 4, 5 sides, so it's a pentagon. And they all look different depending on, the length of the sides. Each flat surface is a side. It's also called an edge, especially when we get to three-dimensional. Each vertex or each point is called a vertex. And then a diagonal just goes from one vertex to one that's across from it, not one next to it, because that's just a side. All right, so the first thing is we want to tell whether they're polygons or not, and if it is, name it by the number of sides. If it's not, tell me why it's not a polygon. So the first, and if you want to try these, you can. The first one's not, because we got this open part here, so it's not a polygon because it's open at the top. Not everything's connected. The next one is a polygon. And how many sides? So I'm just going to mark where I start. 1, 2, 3, 4, 5, 6, 7, 8, 9 sides, which makes it, if you can't remember, look at your chart for now, nonagon. It might be helpful to make some flashcards. All right, and the last one is not a polygon because it's rounded right here. If you look at the definition, line segments only, but no curves. So no, because of this guy right here. They all got to be flat surfaces. All right, a couple more terms to talk about. A regular polygon, all the sides are congruent and all the angles are congruent. Concave and convex. Concave, and this, I apologize, there's a few things that didn't show up in your packet. Concave, a diagonal can contain an exterior point. So I want you to kind of draw this. I like to think of it as something that's been caved in. Do you see how this caves in? Right here, it's caved in. So like a star would be concave. Where it's caved in, that means that it's concave. And the whole diagonal thing, if I were to draw a diagonal from here to here, it's not inside of my shape, it's outside. You can't have that. Convex means the diagonals don't contain any exterior points. So like this is an example of convex, this 1B up here. All right, so let's do some examples. Tell whether each polygon is regular or irregular, and tell whether it's concave or convex. Again, the markings didn't show up very well in yours, so if you want, you can add them. All right, so this is irregular because not all the sides are the same. All the angles are okay, but not all the sides are the same. So it's irregular. And do you see any parts that are caving in? No, so it's convex. The next one, all the angles have the same marking. And again, you don't see this on your paper, so you might want to add it. All the sides are the same as well, so that is regular. And it's convex. And by the way, all regular figures are always convex. Now, this one looks like it might be regular because if you look, all the tips, those little angles are the same and all the sides are the same. But look at right here. This is an angle too. So is this. All right, so it's actually irregular. And it's concave because it's caved in right here and right here. It's like it pushed in, it caved in. Anything that's concave will always be irregular. All right, one of the most important parts of this particular lesson is talking about your interior angles. And they all relate to a triangle. So we know there's 180 degrees in a triangle, right? Well, as you add a side, you're basically adding another 180 degrees. So if you pick one point and you draw a line or draw all the diagonals, well, you've got this side, you got this diagonal, and then you got this side. Just going from one point. We have a triangle here, we have a triangle here. So those add up to 360 degrees. So in any four-sided figure, it's always going to be 360 degrees. Any three-sided figure will always be 180 degrees. For a pentagon, if you look, you got one here, breaks it up into 3 triangles. So again, if you add those all together, you get 540. So every single pentagon, the interior angles are going to add up to 540. Same with this hexagon. Again, just go from one point. It doesn't matter which one. This will give you the same thing. Break it up, go to all the other angles, and you'll see there's 1, 2, 3, 4 triangles with 180 degrees each. So every hexagon is going to have 720, which brings us to this table. Basically, if you notice, if you take the number of sides and subtract 2, well, basically, it will tell you how many triangles there are. So 3 minus 2 is 1 triangle, 180 degrees. 4 minus 2 is 2 triangles, 360 degrees. 5 minus 2 is 3 triangles, all right, 540 degrees. So basically what's happening is this formula down here, for any polygon, the sum of the interior angles, and you definitely 100% need to memorize this, the sum of the interior angles, that means all the interior angles together, you take the number of sides minus 2 and multiply by 180. For the sum of the exterior angles, it's easy. It's always 360 degrees. So no matter how many sides you have, the sum of the exterior angles is always 360. But with interior angles, think about how many triangles you can make and then decide. So just subtract 2. So for this next one, find the sum of the interior angles. All right, so let's write down our formula. The more you write it, the more likely you're going to remember it. So it's the number of sides minus 2. We put it in parentheses, so we subtract first, and then multiply by 180. I'm not even going to attempt to draw 15 gone, but there's 15 sides, so I'm just going to do 15 minus 2 times 180. All right, so that's 13 times 180. So 2,340 degrees total in all the angles if you were going to add them up. An octagon, how many sides? 8. So I'm going to do 8 minus 2. Means there's going to be 6 triangles. times 180. 6 times 180 is 1080 degrees because they're angles. All right, what is the sum of the exterior angles of a convex 25 gon? 360 degrees. Exterior is always 360 degrees. If you wanted to find interior, you do 25 minus 2 times 180, but that's not what it's looking for, just the exterior. All right, let me see what we're at for time. I don't want to make this too long. I'm actually going to stop this here before we get into each interior angle. So this is broken up into 2 videos. All right, so we will see you in the next video. Have a great day.